All right, I want to talk some data science concepts with you since I have you on the line. You wrote an article, you said model drift, concept drift, historic time bias when working with healthcare data to train predictive models. It's always prudent to have an extra hold of recent data to make sure the accuracy is the same across time. Help us to understand those three concepts and what you're talking about holding some data back.
Sure. Yeah, healthcare. So when you're doing predictive analytics in healthcare, there are two signals that you're picking up on. There's in individuals like biometrics, right? Like you might think of your vital signs as revealing that you're going downhill or declining, and your lab values can be that way. But there are also there's an overlap there. So there's your vital signs, and then there's your lab values. Your lab values actually overlap with the treatment domain, right? Because a physician making a treatment decision is going to order lab values to monitor the effects of that treatment and also to confirm the justification for that treatment. And once you get into the treatment domain, this is very subjective data. Based on how you are being treated, you will have a different data set. So if we're talking about sepsis and it was pre-2011, I think it was, there were other drugs that were on the market that were pulled from the market. Xigris, I think, I'm just fell out of my brain, but there was a big change in treatment in 2011. So treatment decisions that might predict in your algorithm would no longer predict after that point in time. And that's one big decision, but treatment guidelines and order sets, which are how a health system or a hospital standardizes the treatment that patients receive, these change all the time. And these changes can result in drift in your model if you're detecting decisions, treatments, labs that are no longer available after a certain point in time. Your model might be really predictive when those indicators are available and then drift. There is also another example I think I gave in that post of historic bias related to just general scientific knowledge. And we could see some of this in the COVID pandemic. So early in the pandemic, we believed we were having a very bad flu year. And the very bad flu year myth continued long after we knew that we were in a pandemic because we didn't have testing available. If you recall, there was a real strict criteria for who could be tested for COVID. So even among hospitalized patients, we were never really quite certain who had COVID and who had a bad case of influenza in the beginning until the patterns emerged and became just very obvious to the care teams. So there was an inflection point. After that, we kind of knew just looking at a CT who has COVID and who doesn't have COVID with severe pneumonia. But there was, before that point, we didn't know. So the data was frequently mislabeled. We had cases that looked like COVID, but were labeled as influenza. Influenza is not always tested, so there isn't always a confirmatory test to rely on. And that mislabeled data can send all kinds of wonky signals if what you're trying to do is, for example, detect COVID.